Last class, we talked about limits where we got 0/0 when we plugged our number in, and that indicated to us that we had to simplify things. Today, we're going to look at examples where we get a number divided by 0. So we still have 0 in the denominator, but we don't have 0 in the numerator, in which case we won't be able to simplify, but we will be able to see some fun things that happen. So let's start with this first example. We have the limit as x approaches 2 from the right, 1 plus x over x minus 2. Our first attempt, no matter what we do when we see a limit, is plug that number in, even if it's a right-hand limit or a left-hand limit. So we plug 2 in, we're going to get 3/0. Okay, this is a problem. We still have 0 in the denominator. Do not stop here. Your inclination might be to say, ooh, this does not exist. Don't do that. We need to get a number out or an answer out. So what we're going to do in these cases, when we get 0 in the denominator, we can't simplify anything. So what we're going to do is we're essentially going to think about looking at a table of values, but we're going to do this in our heads. So let's plug in a number close to 2, but a little bigger because this is a right-hand limit. Okay. So if I plug in a number close to 2, the numerator is still going to be essentially 3. I can put it in quotes because it's not going to be exactly 3. So if I plugged in like 2.1, I'd get 3.1. My denominator is going to be a number that's close to 0. Not quite 0 though. And we have to decide whether it's positive or negative. So if I plug in like 2.1 minus 2, that's a positive number close to 0. So I have a positive number close to 0 and a 3 in the numerator. So think about this as like 3 divided by 0.01 or something like that. Type that in your calculator. You get a big number. What if this was 3.0 or 3 divided by 0.0001? We get a really big number. If I had more zeros, so I'm taking a number closer to 2, then we get bigger and bigger numbers. So when we divide by a number that's close to 0, these things are going to blow up. They're going to become big numbers. So this is going to approach infinity. And it's going to approach positive infinity because both the numerator and denominator are positive. This is going to be the case when we get these where I get a number divided by 0, that my answers are going to be infinite or does not exist. So that kind of makes our life a little easier. We have 3 things to choose from: positive infinity, negative infinity, or does not exist. Okay, so let's try that with this next one here. We have x approaching 2 from the left. This is actually the same problem, just a left-hand limit. So I'm going to get 3 in the numerator, still going to get 0 in the denominator. So now we plug in a number close to 2, but a little smaller because this is a left-hand limit. So maybe like 1.99. My numerator is still going to essentially be 3. It'll be a number smaller, just a little bit smaller than 3, but that's okay. It's still essentially 3, positive 3. My denominator is still going to be a number close to 0 because 1.99 minus 2 is still close to 0, but 1.99 minus 2 is negative. So this is a negative number close to 0. So if I do 3 divided by a number really close to 0, this whole thing is going to become a big number, but it's going to be a big negative number this time. So this one is going to approach negative infinity. Okay. This looks like this is telling me that 2 is an asymptote for this function 1 plus x over x minus 2, because we're getting infinities out for these limits. If we look at this next limit is not exactly the same as the previous 2. Notice that we have an x plus 2 instead of an x plus 1. So we need to do a little bit of work here. This is also not a left nor a right-hand limit. When I plug 2 in here, I get 4/0. So once again, we have to do some work. When we see things like this, we need to break this apart into both a left and a right-hand limit and see what's going to happen there. Okay. So we're going to look at our left and our right-hand limits here. So when we look at our right-hand limit, we're going to plug in numbers a little bit bigger than 2. When we look at our left-hand limit, we'll plug in numbers a little bit smaller than 2. So if I plug in a number a little bit bigger than 2, I'm still going to get 4 in the numerator. And my denominator is still going to be close to 0. A number a little bit bigger than 2 minus 2 will give me something positive. So I get positive over positive will give me infinity out here. And that's because the denominator is close to 0. Similar idea with this one, we're still going to get something close to 4 over something that's close to 0, but negative this time. It's a negative sign. So I'm going to get negative infinity out here. My left and my right hand limits are not equal to each other. So that tells me that my overall limit does not exist. Okay. But we still have an asymptote here at -2 because we got infinite limits out. So just an interesting thing to notice. Okay, let's keep going. So this one, if I plug in pi, we're looking at pi from the left, cosine of pi is -1. Cosine squared is going to be +1. And then pi minus pi is going to be 0. So we're getting a number over 0, which means we have to plug in something close to pi, but a little bit bigger. Or a little bit smaller, sorry. So if we plug in a number close to pi, but a little bit smaller, we're still going to get something close to 1 in the numerator. And I put that in quotes because it's not exactly 1, but it's close to 1. We're going to still get something close to 0 in the denominator. And we're going to do pi minus something a little bit smaller than pi. And this is going to be a positive number. So we have a positive number divided by a positive number close to 0. That will give me positive infinity. Okay. One more to go here, guys. This one's not a left nor a right hand limit, so I have to break this apart and look at both the left and the right hand limits. And first I should plug in 2 just to make sure I actually have to do this. So if I plug in 2, I'm going to get -1 over 0. So I do have to do this work. So I'm going to get, if I look at my right hand limit and I'll look at my left hand limit. Since I'm plugging in numbers, I don't have to worry about the absolute value like I did last time. I can leave it as an absolute value. Okay, so I plug in a number a little bit bigger than 2. My numerator is still going to be close to -1. My denominator is going to be positive because of the absolute values. It's going to be close to 0. And so I'm going to get negative infinity divided by a positive number close to, or -1 divided by a positive number close to 0. That's going to give me negative infinity. Exact same thing's going to happen if I plug in a number a little bit smaller than 2 because the denominator still has absolute values. So we're still going to have a positive number close to 0. So I'm going to get negative infinity out. Since these agree with each other, that means my overall limit, my goodness, guys, I can't talk. My overall limit is negative infinity. Okay. So notice that when we get a number divided by 0, we have 3 possible answers. We either get does not exist or plus or minus infinity. The does not exist is the case where the left and the right hand limits were not equal to each other. Okay. In the cases where when we plugged in a number and we got 0 over 0, that was when we simplified. Okay. So these are really how we deal with limits algebraically. It's not terrible. You just have to understand how it all works.